Hello everyone, I'm Maurice Monene. In this session we are going to discuss how we can determine the root of the equation using the factorization method. And with me here I have an equation that reads a curve is defined by the quadratic function y is equals to 12x minus x squared minus 20. Determine the root of the equation using the factorization method. So in this equation we know that we have, maybe if I take my writer here, if we are to factorize this, we have 12 x then minus x squared minus 20 is equals to 0. So in this case we can have negative x squared then plus 12x then minus 20 is equals to 0. So to factorize these, we are going to have our product here. We take the coefficient of x squared, which is negative 1, then multiply by negative 20, and this one we get the product being positive 20. And then we know that our sum here is 12, so we get the two products that we can multiply to get 20, and at the same time add them to get 12. So we have 10 and 2. So in this case, where I have 12x, I can substitute with 10 and 2. So I'll have negative x squared then plus 2x then plus 10x then minus 20 is equals to 0. So I can group them so that I can be able to factorize them. So here I'll have negative x. When I factor out negative x here, I'm going to remain with x minus 2, and here when I factor out the positive 10, I'll be left with x minus 2. So now I can have my values being, I have negative x plus 10 and x minus 2, and this equals to 0. So I can conclude that my first value here is negative x then plus 10 is equals to 0. So my value of x here is equals to 10, and then the second one is x minus 2 is equals to 0. So my x is equals to 2. My x is equals to 2. So that's how we can find the root for that. Remember, the root for this now becomes 2 and 10. So if we are to draw that curve in our quadratic in our Cartesian plane, it will cut the x-axis at 2 and 10, and that brings us the root of that equation. So hence we can go ahead and solve by using the calculus techniques to determine the turning points, of this. So by using of the calculus, determine the coordinates of the turning points of the curve. Remember, our curve was y is equals to 12x then minus x squared then minus 20. So we know that at the turning point, the value of d in respect to dx, that is the equation differentiated, will be equivalent to 0. So we differentiate this equation, and if we differentiate these, we are going to have the dy dx equivalent to 12 differentiated. This becomes x raised to power 1 minus 1, then we shall be left here with 12, then minus 2x. So, and we can substitute the dy over dx with 0, so we have 0 is equals to 12 then minus 2x. So in this case we are going to get the value of x being, we make x the subject of the formula, so we are going to be left with x is equals to 6. So now we can come and substitute these in the equation so that you can get the value of y. So we know that y will be given by 12 multiplied by 6 then minus 6 squared, then minus 20. So when we take 12 multiplied by 6 here, this one we get 70, we get this one as 72, then minus 36, then minus 20. So remember this one is equivalent to y. So you realize that our value of y is equivalent to 16. So now the turning point, we can conclude that the coordinates of the turning point of this curve is 6 and 16. 6 and 16. And that brings us to the end of this session. I was your trainer, Maurice Moneni. If you found this video of importance to you, please consider subscribing, like and share it to many platforms so that you can reach more students to have the same knowledge. Thank you.